you already have your correct name on there, so that's perfect. So you will get the extra credit. So starting off, do you have any questions at all on like the Zybook stuff for your homework?
Can you hear me?
Yeah, I can.
I'm sorry. Can you also see it's pretty loud where I'm at, so I think it's best if I probably just like type it in the chat. That way you don't have like a bunch of background noise.
That's all right. Yeah.
Okay. But as of right now, I don't have any questions. If anything comes up, I'll make sure to let you know.
All right, perfect. All right, so first of all, I'm going to start talking about the cmath library. So this is another library that we can add to our programs to increase the functionality. So this is just like how we add IOmanip or IOstream to the programs. It just increases what we can do in them. And this one in particular adds additional math function. So if you ever have a program where you want to, for example, use absolute value or an exponent or something like that, you are going to, at the top of your program, write this in hashtag include cmath in angle brackets. And what this allows us to do is it allows for some additional math stuff. So these are the three that you will be seeing in this course most frequently. So there is a whole list of them right here, but you don't need to worry about memorizing all of those. They're just here if you want to refer to them at any time. But the three that you're going to want to know are POW, square root, and fabs. So POW we use for exponents. And if you ever want to get a number to a power in your program, you could write that number times itself, times itself, times itself, times itself, times itself, times itself, however many times, or you could use the POW function. So if in my program, I wanted to calculate 2 to the power of 3, what I'd do is I'd call the POW function, and then I'd put the base first. So the base is 2. So I do 2, comma 3. And this is going to just perform that calculation, and this would result in the value of 8. So this whole thing, all these numbers, just result in a single value of 8. So that is POW. And of course, I could do that with either direct numbers or if I had variables to store those numbers as well. Secondly, we have square root. And this is the exact same thing as the square root symbol and then a number in it. And this will just return the square root of whatever number you put in the parentheses. So if I wanted to find the square root of 2, this would be the same thing as writing SQRT of 2. And it's going to just result in that 1 point dot value that the square root of 2 is. And then the final one is fabs. And this one could have been named a little bit better, but it's kind of in there, this abs part. It stands for absolute value. And it gets the absolute value of any number. So you would call fabs followed by the number that you want to take the absolute value of. So if I wanted the absolute value of -9, I would write fabs -9 in the parentheses, and this would just return the value of 9. And when I say return the value, basically it's the exact same thing as saying results in. This whole expression will end up just resulting in that one single number. Do you have any questions on these three? All right, cool. So now we are going, well, there's all of these ones here too, if you ever want to use them, but we shouldn't be using those in the course because they're a little bit more advanced math-wise, but they're there. And now we're actually going to get a little bit of practice writing these cmath functions. We should be using the square root as well as the POW function in this one. And what we're going to do is we're going to write a program which will take 3 inputs from the user for A, B, and C, and then calculate the roots of a quadratic. So what we're going to do is I'm going to switch screens to an empty text editor, and I'll just have you help me out with what you think I should write here. So we're starting off a C++ program. What is the very first few things, like this very basic structure? Yeah, there you go. Hashtag include. We got to figure out what additional libraries do we want. And the first one that we want to put is IOStream, because our program is going to have input and output functionality, and that IOStream allows for that. I'm going to just really quickly change this to a CPP file so we get the syntax highlighting. All right, perfect. And next, we actually want to include another library. What do you think that's going to be?
Would it be like the cmath library?
Yeah, very good. We are going to include cmath because this is going to allow us to use the square root function, which we are going to need in this program. All right, so those are the two libraries that I think we're going to want to include. And we also have to say using namespace std with a semicolon at the end. And this also allows for input and outputs. Okay, so next we need the little box that all of our program goes in, the function. What one is that one? Int main, perfect. Parenthesis and curly braces. So our entire program is going to go inside of those curly braces. And the last part of the structure of our program is return 0. And this just will return a value back to the computer, which will, if it's 0, effectively tell the computer that our program ran fine and everything was okay. All right, so next we're going to look at the instructions. So it says that we ask for 3 input values for A, B, and C. So I think that's a good place to start, is to start with taking input. And how we are going to do this is, well, how do you think that we're going to do it? How do you think we're going to take input for 3 numbers?
We have to use like the C different input.
Yeah, we're definitely going to use cn. So the syntax for that is cn, and then the little caret operators, but we actually have to tell it where do we want to put the information. And anytime that we want to store information in C++, it's going to go into a variable. So I'm going to go ahead and create a variable. So I'll say double, and I'll just call it A, because we're going to input for A, B, and C. So I'll call this one A. And I'm going to just say cin, and then whatever variable I put here at the end of the cin statement is what it's going to take input for. And I chose double because sometimes the zeros of the quadratic will be decimals, and we want to allow for that calculation rather than it. All right, so we have input for an A, then I'll just do double B, and then we can take input for B. And lastly, we'll take input for C. And I got to define that. C. All right, so that is taking 3 inputs. And now I'm going to run the program to make sure everything is working properly. So I'll do G++ and then my program name. And we got no errors that came back, so that's good, which means that we got an executable. And if you notice here, it's kind of just waiting. It's not doing anything. And what it's actually doing, if we look at our program, the first action statement that we have here is to take input for A. It's actually just waiting for input for A, but it's not very descriptive. So a lot of times when we take input from a user, we want to create what's called an input prompt. And what this is it's a cout statement that happens before the cin, which basically just lets the user know, hey, you should probably type some input here. And that would be really helpful to me if, well, the program, basically just the program just telling the user, hey, put some input. So we're going to write a cout statement right here, which is going to just have a quick little description of what you want the user to do. So I'll just say cout. My double quotes indicate a string literal. So this text is going to just literally output to the console. So I'll just say enter A. And if we ran the program again, okay, there we go. And if I saved it, so we've got to recompile because we made changes and then run the executable. Now it's a little bit more friendly and it actually prompts us with a statement. So now if the user were to enter a number for A, it is a lot more friendly. So I'm going to do that for the rest of the inputs. All right, so that takes care of that. So now we have taken input for 3 values. And next we have to calculate what x is based on those inputs. So we are going to apply this quadratic formula and figure out how to write it in code. So we know that we need to find the negative of b, and then we got to do plus minus the square root of b squared. Somehow the square isn't in there, minus 4ac, all of that over 2a. And we are going to figure out how exactly we are going to write this in code. So do you have any ideas what we might want to do here?
Did you repeat that one more time? I'm so sorry.
Oh, it's totally fine. So what we're going to do is we took inputs for A, B, and C. So the user just entered 3 numbers for us. And our job now in the program is to calculate the zeros of a quadratic. Are you familiar with the quadratic equation in zeros?
Yeah.
Okay, cool. So what we're going to do is we are going to write a program which will basically have the user enter A, B, and C, and every single time it's going to give us the roots instead of us doing like the long calculation by hand. So we are going to need to figure out how in code we can actually represent this formula. All right, so I think a good place to start here would be to talk about just basic calculations in C++. So are you familiar with like the arithmetic in C++? Just like basic arithmetic?
I don't know, honestly. I took some notes from last class. I'm not sure if that's what you're referring to.
Here, you know, we can
about.
sidetrack a little bit. So in C++, I'm going to open up a different presentation from last week. There we go. So in C++, math is actually a thing that we do quite a bit, actually in all programming. And it turns out that the operators to do this are pretty similar to those in just regular math. So addition is just a plus. So if we wanted to add 2 numbers, it would just be a plus b. And subtraction is the minus symbol. Division is the slash. Multiplication is a star. And it's important to note for multiplication that a, b, like 2 variables directly next to each other, will not perform multiplication like they do in math. Along with a like times b, that doesn't quite work. Along with like a number and a parenthesis, it doesn't perform multiplication unless you have this little star. So that's an important thing to remember. Another operator that we have in C++ that you might not be familiar with is this one called modulo. And what modulo does, it gets between 2 numbers, it will get the remainder of those. So if we were to do division on a calculator, for example, like 9 divided by 2 on a calculator would give you 4.5. However, if you were to do it a different way, like the long division way, 9 divided by 2, you would say it's 8, and then you have a remainder of 1. What modulo does is it gets this remainder right here. So if we said 9 modulo 2, this would result in 1. That's all that one does. And one more thing to note that's a little bit different. So modulo is something that's a little bit different than regular math. Another thing is in division, there is a very key difference between ints and floats. So if you remember, when we are defining variables, we have to define their type. C++ is very specific about this. We have to say int a or double A. And the type can actually really affect our calculations. So if we had int a, and let's just say a had the value of, I don't know, 9. I'll just do 9 again. And I had int b, and b also had the value of 2. And if I said a divided by b, and I just printed this, and I just printed that to the console, what would be your natural instinct of what this is going to print? Well, you might say 4.5, because 9 divided by 2, if you were to do that on a calculator, you would think, okay, that's going to be 4.5. However, you have to note that this is an int, and ints can only store whole numbers. So when you're doing a calculation with 2 ints, it's only going to be able to have a result that's an int. So instead of printing 4.5, you would print 4. And I'm actually going to show this to you because this is kind of important. So if we have our code here, and I just did that, COUT A divided by B. And in the terminal, if I were to run this, okay, and ran the executable. So it's entering a number for A, we said 9, and B, we said 2. So A divided by, what in the heck? Oh, it's doubles. That would be why. If these are ints, this is the point I'm trying to make, that it should be doubles. Save that. We dot out, and we entered 9 and 2. And we get a 4 here, if you see that on the terminal. And the reason is we had an int A and an int B. And when we have 2 integers that are dividing, it performs what's called integer division. So if we ever get a fractional or decimal part, what the compiler is actually going to do is it's going to just cut it off, as you just saw, which leads to inaccuracies in some calculations. So if you ever want very specific division where you're expecting decimals, it's important to note that A and B, or whatever variables you're dividing, should be doubles. And that's about it for the operators. The only other thing is parentheses function exactly as they do in math. So if you want a part of an equation to happen first, the parentheses are going to make that happen. So otherwise, it's just order of operations. Okay, so I think that gives a quick overview on the different operators that we can use. So there's 2 ways that you can output an equation to the user. The first way is what you just saw. We can just put it right in a cout statement as a part of it and just output that directly to the console. So the benefit of this is it's very short. It's very short, it's concise, it happens all in one statement. The other way to do it is you save the answer first and then you output it. So what you'd have to do is you'd create another variable, and then you would say that variable that you just created is assigned with the equation that you want to perform. So assignment statements go from right to left. So whatever's on the right side gets assigned to whatever on the left side. So what's going to happen is it's going to calculate this value, and then it's going to assign it to answer, and then we print it afterwards. So the benefit of this is you get to actually store it. You store whatever calculation that you just made. So if you want to use it again later in the program, it will be stored in the variable. And the downside of this, I guess, is it's longer. So it kind of just depends on what you want to do with the calculation. Questions on the basic arithmetic before we go back into the quadratic formula? All right, cool. So now we are back to this. And everything is back to doubles. And we are all set. So now that you know a little bit about how we can store and print calculations, what do you think is a better way to do this? Should we print it directly to the terminal using a cout statement? Or do you think we should store the calculation and then print it? Store it. Yeah, that's a really good idea because, well, it's just nice to be able to have it stored and we can use it later on. And it will keep the calculation a bit more clear. So we are going to make a double. And I'll just call this one X. All right, so now we have X is going to be assigned with, and over here is where we put our equation. So if we remember the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So breaking that down, what do you think the first thing that we want to do here is? Let me see if I can actually bring the picture on my desktop. There we go. All right, so the first part of the equation is to find negative b. And we're going to just write that, negative b. That takes care of that. All right, so now plus minus, was that an operator that was on the list? No, yeah. So what we're actually going to have to do is we're going to have to make one calculation, which is going to take care of the minus, and one calculation, which is going to take care of the plus. And in that way, we will get two results for x. So I will turn this into x1, and we'll make another one for x2. All right, so the first one, let's do plus. So b plus the square roots. So how do we do a square root?
Don't you just put like SQ?
Let's see. Yeah, perfect. So we say SQRT, and then we put parentheses here. And whatever goes in the parentheses is what we are going to find the square root of. And if you remember parentheses, those happen first, right? So what's going to happen here is it's going to do the calculation that we put in the parentheses, and then it's going to square root that. So over here, we have b. So we'll write b, that's in the square root, minus 4ac. So I can't write it like this, 4ac. Why? Why can't I do that? Well, the reason.
Oh, sorry.
Yeah, go for it. Go for it.
Don't you have to like use the sign to like make sure that the computer knows you're trying to multiply it, or else it wouldn't multiply them again?
Exactly. Yeah. Whenever we want to perform multiplication, we actually have to implicitly write the star character. Otherwise, it's not going to actually perform multiplication. All right, cool. So we have negative b plus the square root of b minus 4ac. All right, nice. This is actually needs to be b squared. This is not correct. I'm looking at it too much. Okay, how would we write b squared? There's two ways to write this.
But using power.
Yeah, definitely. We could say pow. And then the first number that goes into the pow function is the base. So the base would be b. And the second number is how many, like what is raised to, the exponent. So pow b2. You could have also done b times b, would have done the exact same thing. But the pow function is cleaner, and it's also good to get used to it. All right, so now we have done the numerator. Now we have to do the denominator. So division is the slash. And then down here, we could write 2 times a. But one thing to notice here is what order of operations is going to happen here? Is it going to do this top part separately, or do we need to add some parentheses?
I think we would probably have to use parentheses, right? Or no?
I think you might want to use parentheses, and the reason being is this is going to follow order of operations. So what it sees first is we're going to do all of this stuff. It's going to do the parenthesis, and then it's going to go for this divided by 2. So it's going to calculate this stuff, and then it's going to divide that by 2, and then it's going to multiply it by a, and then we're going to add negative b. So that's all out of order. And how we fix that is we're going to just put parentheses around what we want to happen first. And I want this calculation to be separate. So now it's going to calculate this stuff. Then we're going to add negative b, but then we're going to divide by 2. We want this part to happen separately. So we're going to put this in parentheses as well. So we're going to multiply a by 2, and then we're going to divide everything. Does that make sense? Okay, cool. All right, so now we're going to just do the same exact calculation. So we can copy and paste this. And all we're going to do is change the sign. So instead of plus b, we will do minus b, and adding a semicolon. And just defining those variables real quick. And there it is. All right, so now we have the calculation for x1 and x2. And now that they're stored in those variables, I'm going to just make sure that everything is happy with the program and there's no errors. So we didn't get any errors back, so that's good. And now we're going to just print this. So I'll just write a cout statement that says x is, and then I will just put the 2 calculations that we found. So x1 or x2. All right, so now we are going to see if this works. So I will save it and compile. So we didn't get any errors, so that's good. And now we are going to run the program. So it looks good so far. It says enter a number for A. I'm going to do one that I know should work without any complex roots. So we'll do 1, -5, and -6. Actually, wait, no, this one doesn't work. Wait, hang on, get out of this. Okay, well, I found it anyways. So it said -5 or 0. That works. And we could run it again. And if we did 3, 5, and -7, that also works. Notice this only works for non-complex roots. If I were to do one that was, there we go, 1, 4, and 5, it says x is nan or nan, meaning not a number. This is something that we're going to come back to. Wouldn't it be nice that it would actually correctly alert us, hey, this is not a valid calculation, it's actually undefined. Try different numbers, basically. And what we're going to learn next is using if statements, which will actually make decisions. And this program will be able to determine if it's not a real number, print this statement. If it only has 1 root, print just one of them. If it has 2 roots, print both. And that is going to be done using decision making. And when we do decision making in C++, we use what are called if, else if, and else statements. But before I get into that, I want to check in with you and see if all of this makes sense at the moment with the using square root and POW and just little basic calculations.
Yeah, it makes sense. I just feel like I kind of need to do it myself, kind of to like understand it a bit more.
Yeah,
But
definitely. Um, about that, actually, let's see. I'm going to open up your textbook, Zybooks. And I don't think that Steve has assigned this section to you yet, but if you're interested in playing around with those math functions, there is a section on here. So when you open up your textbook, it should look something like this, where you have all these sections. And the section 2 on variables and expressions is going to walk you through all about the different variables, the data types, and then just some arithmetic expressions. And in addition, those cmath functions are right here in 2.9. And what it does is it'll walk you through some activities where it shows like the flow of the program and what's happening step by step. And it has all of these functions here. And you get to practice. The square root of 36.0 evaluates to 6. And you just go through these questions and you'll get to answer all of them. And at the very end, it also has some programs for you to work through, where it says compute z is assigned with y times the absolute value of x. And when you do this, you'll press the start challenge button and you are going to write the code yourself on how you think that you would complete this calculation. And if you want to, you could actually do some of these Zybooks activities right now and you could work through them and I can help you out with them. You want to do that?